Okay, so good day everyone. For today's tutorial, we'll talk about the simple interest, specifically about the exact, approximate, ordinary, and actual simple interest. So first, there are two kinds of times in regarding the simple interest. So you have the exact time and approximate time. So for the exact interest, so we assume that there are 365 days in a year. So we have the number of days all over 365. 366 if leap year. We can know if the year is a leap year if it is divisible by 4 or multiples of 4. And then for the ordinary interest, we assume that there are 360 days in a year. So we have number of days all over 360. So example number 1, find the ordinary and exact interest on 15,300 for 90 days at 7 and 3.5% simple interest. So we have the given of principal, which is 15,300, and then the time of 90 over 360 using our ordinary. We have the rate of 7 and 3.5 or 7.6 or 0.076. So we have the ordinary interest of 15,300 multiplied by 0.076 multiplied by 90 over 360. So we have the ordinary interest of, simplifying the values, we have 290.7. Okay, now that using the exact simple interest, so same process, but this time our time is 90 over 365. So simplifying the values, we have exact simple interest, we have 286.72. Note that ordinary interest is greater than exact interest. When interest is not specified in any problem, it is assumed as ordinary interest. So let's have an example number 2. So Luffy borrowed 30,000 berries from a financing company charging 11.8% simple interest for 180 days. Now the question is, how much did Luffy pay back the company at the end of the term? So we have the given of P is equal to 30,000, T is equal, or the time is 180 days all over 360, and then the rate is 11.8% or 0.118. So computing the ordinary simple interest and then substituting the values, we have 30,000 times 11.8% times 180 over 360, and then simplifying, we have 1,770 for the simple ordinary interest. Ordinary simple interest. And then computing the total amount, we have principal times add plus by the interest. So we have 30,000 plus 1,770. So the total amount is 31,770. Therefore, Luffy must pay the company 31,770 berries at the end of the term. Okay, now let's practice. So go grab your scratch paper and ball pen or pen, and then you can pause the video if you are not yet done, and then unpause it if you are done. Okay, now that the Hunter Pawn Shop charges 27.3% simple interest on the loan value of all items pawned to them. If Kurapika pawned his chains for 2,300 pesos, how much will he pay for the pawn shop after 90 days, assuming the Hunter Pawn Shop charges the following? So exact interest and then the ordinary interest. Okay. We have the answer. So you can check if you got the answer right or wrong. So if you got the answer wrong, you can go back and check if you miss any steps. Okay, so we have the Gregorian calendar. So we are using it currently in our time, in our age. So this is our calendar that we use today. And then we have the handy dandy knuckle calendar. So we can use it to count how many days in a month. So for January, we start with 31 days. And then February, usually it is 28. But if it is in leap year, it is 29 days. And then for March, 31 days. And then April, 30. And then it is alternating. And then if we go for August, we start with 31. And then September, 30 days. October, 31 days. November, 30 days. And then December is 31 days. Okay, let's have an example. So find the actual and approximate time from March 23 to October 16, 2020. Okay, so we have, since we start with March 7, March 23, and since March has how many days? It has 31 days. So we simply subtract 31 subtracted by 7, 23, so we have 7 days. And then for April, 30 days. And then in May is 30 days, and the rest is 30 days. And then until October, since we stop at October, we will only count it as 16. So using the sum of it, we have the approximate days of 203 days. And then for the actual time, so using our Gregorian calendar, we simply substitute those values. So we have 207 days. So as you can see, the actual time produces more days than the approximate days or approximate time. Okay, for example, we can see that 2020 is a leap year because it is divisible by 4. But because we can only identify the number of days from March to October, February will not be a problem. It has been 20 days, so we must consider the number of days left in March. We can see from our knuckle bumps and knuckle gaps that March 31 actual days in the Gregorian calendar, so the answer is 8 when 31 is subtracted from 23. We always consider all months with 30 days when calculating approximate days. So March is only 30. So here 30 minus 23 equals 7. So take note, it is for approximate days. Okay, example number 2, find the actual and approximate time from February 2 to August 3, 2020. So here's our solution. So as you can see, we start with the month of February, and since, take note, it is leap year, so we, from the actual days, we count it as 29 days minus 2 since we start with February 2. So we have 27 days for February, and then 31 days for March, and then it is alternating until for August 3, since we end with August 3. So we have the actual days of 183 days. Whereas for approximate days, we just assume that all of them are 30 days. All of the month are 30 days. So we have 30 minus 2, so we have 28. And then adding them up, so we have 181 days for the approximate days. Okay, now let's have a practice exercise. So go grab your scratch paper and ball pen or pen. So I want you to find the actual time and approximate time between the dates indicated. So you have letter A, August 22 to December 2, November 2, 2009 to March 2, 2010, and then October 13, 2003 to February 14, 2004, Okay, you can pause the video if you are not yet finished, and unpause it if you are done. Okay, now let's check your answers. So if your answers are same as in this slide, so you are correct. But if not, you can go back to your problem and check if you have missed any steps. Okay, when interest is to be computed from a certain date to another date inclusively, there are four methods of computations. So we have ordinary interest for actual time, or the banker's rule, actual over ordinary, and then ordinary interest for approximate time, so approximate over ordinary, and then exact interest for actual time, or actual over exact, and then exact interest for actual time, or approximate over exact. Okay, now let us practice. So find the interest using the four methods. So in this four, and then try to solve on 30,000 at 4.5% from August 2 to 2020 to November 27, 2020. Okay, you can pause the video if you're not yet done, and then unpause it if you are done. Okay, now let's check your answers. Okay, for the actual or actual time, we have 117 days, and then the approximate, which is 115 days. So here's our solution. Okay, for the actual and ordinary combination or method, so it yields 438.75 pesos. For the approximate over ordinary, it yields 431.25 pesos. And then for the actual over exact, we have 431.56 pesos. And then for approximate and exact, we have 424.18 pesos. Okay, now let's try to solve this problem. On May 30, 2012, Sanji borrowed 15,000 berries from Nami for the expansion of his restaurant. It was agreed that he would pay the amount with 25% interest rate on August 10, 2012. What is the exact simple interest using the actual time to be paid? So take note, we are using only the actual time. Okay, so we have the given of principal amount of 15,000, and then the rate of 25% or 0.25, and then the time of using the actual time, we have 72 days. So substituting the values, we have 15,000 times 25% times 72 over 366. So we use 366 since it is a leap year, since 2012 is multiples of 4 or divisible by 4. So we have the actual and exact simple interest of 737.70. Okay, now let's try to practice solving the problems. Okay, if you are not yet done, you can pause the video. If you are done, you can unpause the video. Okay, so here's the answer. You can check the answer if you got right. If you got the wrong answer, you can go back to the problem and check if you miss any steps. Okay, that would be all. Thank you for watching.